Okay, so we are doing solving rational equations. Okay, so what I want you to realize that's different today is that we actually have equations. Everything we've done before today has been expressions with no equal sign. So we actually have equations, which means we actually are solving and looking for answers. Okay, so knowing that, we still have a lot of the same steps to start. Okay, so we still need a common denominator because this is subtracting. Now, I'm going to bring that subtraction up here so I don't forget, because I know when it's down here, a lot of times we forget about it. So I have this, and we need a common denominator. What do you think our common denominator is going to be? Huh? Remember, this is its own factor, and this is its own factor. So it's going to actually be both of the factors together. And knowing that that's going to be our GCF, we can go ahead and find our domain before we even get started on solving. Okay, so what would make this positive 2 turn into a 0? And what would make this negative 5 turn into a 0? So we know that no matter what, x cannot be negative 2 or 5. So now that we're actually solving, y'all, we actually have to pay attention to our answers in our domain and look at them together. Okay, so we'll get there in just a second. So eventually we're going to find our solution, but we don't know that yet. So that's where we are here. I'm going to rewrite this because I'm going to spread it out a little bit so y'all can truly see what I'm doing. Because I moved the negative up. I just put it up so we don't forget about it. Okay, and I'm going to write this over 1 because everything has to be a fraction. Okay, and now we need to make our denominators common. Okay, we need to make them the same. So this is x minus 5, but it doesn't have the x plus 2. So what I do to the bottom, I also have to do to the top. This is the x plus 2, but it doesn't have the x minus 5. And this has nothing. So technically, when I give it the x minus 5, x plus 2, x minus 5, x plus 2. Now do my denominators match all the way across? Okay, the best part about this, because you cannot do this when you're simplifying expressions, the best part about equations is that when the denominators all match, you can cancel them and no longer have fractions. The way you do that, well, technically, a fraction just means divide, right? So how do you get rid of division? So if I multiply this whole equation by this x plus 2, x plus or minus 5, then all that does is cancel all my denominators. So obviously you don't have to show that step every time. Just know that once you have a common denominator, you can cancel the denominators. Okay, so knowing that, now we're literally just solving the top. So let's go through and figure out what that is. So 7 times x is 7x. 7 times negative 5 is negative 35. Negative 6 times x is negative 6x. Negative 6 times 2 is negative 12. Equals, well, what's 0 times anything? 0. So nothing really even changed on the right side of the equal sign on this one. So knowing that, I'm solving by just solving for x because there's nothing squared, there's nothing weird about this one. We are just going to get x alone. So I'm going to combine my like terms. So I have this negative 35, this negative 12, this 7x is negative 6x. So what is 7x minus 6x? And negative 35 minus 12? And now how do I get my x alone? And I get x equals 47. Can x equal 47? Yes. So my solution is 47. Yes. Yes. because that would be if I just needed to multiply a number to change it. But if I multiply x plus 2 times 2, that gives me 2x plus 4. But if I multiply this one by 5, I get 5x plus 10. And if I multiply this one by 2, I get 2x minus 10. They're still not the same. So when you have plus and minus, you're really just kind of multiplying your denominators by each other. Okay, so we're going to write down our steps here. So our first step is find your LCD and implement it. Give them all a least common denominator. Okay, 2 was cancel your denominator. And 3 is solve. I don't know what I was writing here. That's an L, not a D. Okay, so let's look at our next problem. Okay, so on this one, let's go ahead and find our LCD. And I'm just going to write solution here. Okay, so what do you think our LCD is going to be here?
Positive 2 and negative 2.
You're missing something.
And negative 3.
X minus 2, x plus 2. Okay. Because this one has x plus 2, while these both have x minus 2. And remember, they have to be the same, and we have to make them the same by multiplying. And the only way you're going to do that is by multiplying them by each other. So again, I'm going to write it out so y'all can truly see everything I'm doing. You don't have to do this piece. I'm just doing this so that way it's not so cramped that y'all can't tell what I'm doing. So before I even do anything, though, I'm going to distribute my negative. Now, on the first one, when I gave the top the negative, there was only one term, so I just kind of moved it. But here, you have two terms that you're subtracting, so you have to give it to both. So this becomes negative x plus negative 2. Okay? And now we're going to figure out what we need to multiply by to get common denominator. So this is an x plus 2. I'm missing the x minus 2. This is the x minus 2. I'm missing the x plus 2. Missing the x plus 2. Because it was minus, I distributed the negative. Okay, so knowing that, y'all, what do we do once we have denominators that match? We cancel the denominator, okay? Sorry, I'm thirsty. Okay, so once we cancel the denominator, what do we do to the top? We solve. So we're going to distribute x times x is x squared. X times negative 2 is negative 2x. Now I want you to realize this is kind of its own factor too, so you're double distributing. Negative x times x is negative x squared. Negative x times 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times positive 2 is negative 4. And again, double distributing, x times x is x squared, x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. And now we're going to combine like terms. But what's different about this problem so far from number 1?
It's not 0.
It's not 0, but don't we have something squared this time? Can you just get x alone to solve for squareds? No, we're going to have to factor. Okay, so let's get going first. So I want you to realize we have x squared, because remember we've got two sides of our equal sign. Here we have negative 2x, negative 2x, negative 2x, and then this 4 that's all alone. What's x squared minus x squared? They cancel each other out. Negative 2x minus 2x minus 2x is negative 6x. This negative 4 has no like term on this side. Here we have x squared. We have plus 2x plus 3x and a 6. Well, the only two like terms on this side are those two. But because we still have a squared, we need to get it equal to 0 so we can factor. Okay, so I'm going to add 6x to both sides. That zeroes out. And then I'm going to add 4 to both sides. That zeroes out. And I get 0 equals x squared plus 11x plus 10. Okay, and this is where we have to factor it. Yes. So a times c on top, well 1 times 10 is 10. B is 11. Ax, well 1 is x. Ax, 1 is x. What multiplies to give us 10 but adds to give us 11? Yeah, this is a pretty easy one. So x plus 1 and x plus 10. So remember, when solving using factoring, you literally just set both of your factors equal to 0 and solve. Minus 1, x equals negative 1. Minus 10, x equals negative 10. Now, before I figure out my solution, I need to know my domain. What can x not equal? What would cancel a negative 2? And what would cancel a positive 2? So we know that x cannot be negative 2 or positive 2. But I have negative 1 and negative 10. Are those okay? Yes, so I can have both of those. Remember, proper is to write them least to greatest. If you don't, I'm not going to mark off, but that's proper. So just remember, this was me just rewriting it. You could have done all this work right here. I just rewrite it so it's not so cramped and y'all can truly see everything I'm doing. Okay, so you're going to flip to the back.
Oh boy.
It's not bad. You are. So I just had somebody tell me on the denominator, we're going to take out a GCF. And the reason being, anytime you have denominators and you have to make it in my own words, you have to make a common denominator or find your LCD, you're going to take out GCFs or factor or do whatever you need to do to make sure that you can see what they have in common. So here, when I take out my GCF, what's my GCF? I'm going to rewrite it. Again, y'all don't have to, but I'm just doing it. But what was my GCF there? 3. And when I take that 3 out, divide by 3, I get x minus 2. Now, does it look a little easier to come up with a GCF? Yeah, because these both have an x minus 2. So what does this one need? An x minus 2. This one has a 6, so I can just multiply this one by 6. Can 3 turn into 6?
Yeah.
By multiplying by what? 2. Oh. Don't forget your x minus 2 right there. Because this was technically 6 times 1. I just kind of wrote over it. But I don't want you to get confused by that. LCD is 6x minus 2. Let's go ahead and find our domain because I forgot about it last time. Okay, so your two factors are 6 and x minus 2. I want you to realize 6, is that okay to be a denominator of 6? Can the 6 ever change? No, because there's no multiplication to that 6. So 6 doesn't mean anything. So what would cancel that negative 2?
Positive 2.
So x cannot be 2. That's the only way we're going to make that equal 0. So now that our denominators match, 6x minus 2, 6x minus 2, 6x minus 2, we can cancel them and solve the top. 2 times x is 2x. 2 times 1 is 2. Don't forget about your equal sign here. 5x times x is 5x squared. 5x times negative 2 is negative 10x. Plus 6 times 1 is 6. Since I have something squared, how do I have to solve this one? We have to do the snowflake. We have to factor. So I need to get it equal to 0. So I'm going to subtract 2x. And I'm going to subtract 2. And that leaves this left side of the equal sign as 0. And I get 5x squared minus 12x plus 4. Oh, it's so cold. What does A equal? 5. B? Negative 12. And C?
4.
So this is where it kind of gets important to make sure you're paying attention. A times C, 5 times 4 is 20. Remember, this is AX, AX. Well, A is 5, so 5x, 5x. And B is just negative 12. What multiplies to give us 20 but adds to give us negative 12?
Negative 2 and negative 10.
Yes, negative 2, negative 10. 5 over 2 doesn't simplify, so that's one of my factors. 5 over 10 does simplify. 5 goes into both of those, so divide by 5, and I get x over negative 2. So then remember, we set our factors equal to 0 and solve. Oop. So we get 2/5 and we get 2, but what can x not equal?
2.
So this is not going to be one of our solutions. What's our only solution? There's your answer. Now, what if x couldn't equal 2 or 2/5? What would be our solution?
No solution.
There would be no solution. Okay, so if your solutions are what we say x can't be, and there's nothing left, then it's no solution. Does that make sense? There is an example like that on your practice, so that's why I wanted to talk about that. Okay, last one. I know this one looks yucky, but it's really not as bad. So again, we said that when we have a denominator, we want to factor and take out GCF. So we're going to factor at the very, very beginning here. So A is 1, B is negative 3, C is negative 18. A times C is negative 18, B is negative 3. A is 1, so 1x, 1x. What multiplies to give us negative 18 but adds to give us negative 3? Almost. It's negative 6 and positive 3.
Oh, yeah.
So this is what that becomes. So I'm going to rewrite this 5 over x minus 6. Now again, I'm going to give that negative to the 4, distribute that negative. And remember, we factored the denominator over here, so I'm going to write it as the factored form. So what do you think our LCD, our least common denominator, is going to be here? It's x minus 6, x plus 3. Because I want you to realize these both have an x minus 6, these both have an x minus 3, or x plus 3, sorry. So I can give this one the x minus 6, give this one the x plus 3, and now they're all the same. So this one doesn't have the x minus 6, and this one doesn't have the x plus 3. And now all of our denominators are the same. But before we keep going, let's find what our domain is. What would cancel this negative 6? And what would cancel this positive 3? So now that our denominators match, we cancel them, and we simplify the top. So 5 times x is 5x. 5 times 3 is 15. Negative 4 times x is negative 4x. Negative 4 times negative 6 is positive 24. Equals x plus 39. Nothing had to change after the equal sign, so it's still what it was originally. So what can we combine? So 5x minus 4x is x. What's 15 plus 24?
39.
What do you notice?
It's the same.
What do you think that means?
And it's gonna equal
It's all real numbers. But what can it not be?
That's just supposed to be an R, right?
It's a fancy R. So your solution is all real numbers except for negative 3 and 6. You can plug in any number in the world and it should work, except for negative 3 and 6. Yes, it'll be not real. You can't divide by a 0, and so you can't use these numbers because it would make a denominator of 0, which your calculator would say error. Like it won't even try. Okay? Now, if you wouldn't have realized these are the same and you would have kept going, you should have subtracted 39 from both sides, and you would have gotten x equals x, which is still equal. And if you even still kept going, you would have gotten 0 equals 0. So no matter what, you see what I'm saying? You can't solve it. It just keeps giving you something that's equal. So if that happens, this is your answer. Okay, so you have a practice